All right, so this is a third lecture of this Python intermediate class. And in the first few classes, we looked at what really the web is, the structure of the web. And we also looked at web requests. And in our second class, we spoke about, we looked into concurrent programming, where I explained what it's really about, the main async with syntax of Python, and how to write concurrent code. So in today's class, we are going to look at object-oriented programming. And after this object-oriented programming, we'll start writing, we'll start doing the more practical stuff, like building APIs with fast APIs and all of that. So I'm going to share my screen now, and today's class will be really practical. We'll be writing a lot of code throughout. All right, can you all see my screen?
Yes, I can see it.
Okay.
Yes, I can.
It's okay. Sorry. Okay. So we are going to look at like I said earlier, object-oriented programming. And when we say object-oriented programming, we are basically referring to a programming paradigm, a programming method that involves structuring program so that the properties and the behaviors of whatever you are working on are bundled into individual objects. We'll really understand what this really means as we proceed in the class. So the first thing I'm going to do is to create a file that we are going to be working with. So I'll call that OOP.py. All right, can you still see my screen?
Yes, I can see it.
Okay. Sorry. So like I mentioned earlier, when we're referring to object-oriented programming, we're referring to a programming paradigm or a programming method in which whatever you're working on is structured, into properties and behaviors. For example, if you're working on, let's say if you're working on something that relates to cars, all right, something that relates to maybe cars, all right, that car is like an object that we are referring here, all right. Then each car has properties, and properties of cars can be something like the speed is the property, the color is a property, that's something that it possesses, its attribute. Then it also has, a car also has a behavior, right? The behavior of a car, one of the common behavior is that it drives. It drives fast or you can drive slowly, right? So that's just what we are trying to talk about. So if you are building a program that relates to cars, right, we can convert this to a kind of a blueprint, an object that has these attributes that I mentioned, and also has behaviors. So we are going to look at more practical examples of that. So another programming paradigm apart from OOP another programming paradigm apart from OOP. Okay, the first one is OOP, that's object-oriented programming, and the second one is called procedural programming. Procedural programming, and procedural programming, whatever you're working on is maybe structured like a recipe, in which your instruction is structured line by line, block by block, and flow by flow. So these are really the differences between these two types of programming models. And the key takeaway in what I'm saying now is that objects are like the center of object-oriented programming, and they are like a blueprint that you can use to model the behavior of the program, whatever you want to do. You can use it to model the behavior. You can use it to also model the characteristics of whatever you want to do. So please, do you have any question concerning that?
Yes, sir. The procedure, is it the same with the functional programming? There's still functional programming.
Okay. Yeah, it should be the same. It should be the same, but I'm not 100% sure because I've not really looked at that at this point.
Okay.
But
All right,
you
sir.
can always check that out on Google.
Okay, sir. I'll do that.
All right. Please, is there any other question? All right. So that's enough with theory. Now we are going to look at the real practical aspect of it. So why are these classes necessary? That's the first question that you need to ask yourself. All right. So if you can confidently build whatever you want to build, using the procedural programming paradigm, why do you really need classes? All right, that's a very good question, and we're really going to look at that practically. For example, let's say we want to like track the students in this Python intermediate class, right? We want to maybe get the data of the students that are available in this Python intermediate class. And first we have del, right? Then we also have uche, member of the class. So let's assume we have a third member of the class. Let's call this member Sandra. Okay, and we need to maybe capture the details of these students, right? For example, the first student is Dell. Let's assume the name is Dell. What's your full name, please?
Huh? What is it?
I mean, you can drop it on the chat.
I don't hear the question.
Okay, your full name, please. Your full name. Or your name. Your full name. Okay. Okay, that's perfect. So let us say our first user is Dell, and let's say our first user is Dell, and the first name is Akintola, and the last name is Martin. Then we want to maybe model the address as well, capture the address as well. This can be maybe 53, maybe 54. Kintola Street. Then we also want to maybe capture the favorite programming language. like Python. We also want to capture the age, maybe something like 24, etc., etc. All right. So doing this for every single member of this class would be very, very cumbersome, and it would be difficult to maintain. All right. Let me copy and paste that for the second person. We have the name of Uche, and maybe the address is 54 J Street, Lagos. Then favorite language is Python, and age is 23. Then let's do that for Sandra. I believe you can all see my screen. Sandra. All right. Hello, everyone. Can you still see my screen?
Yes, sir, I can see the screen.
Okay. So, assuming we are trying to model get the data of the students in this class, and we are storing the data in something like this. Though it's very possible, it's very practical, you can do this, but it's difficult to maintain. Take for example, if let's say you give this to someone, all right, and this person says Uche is a list with the first index of this list is Uche, second index is this, third index is this, and the fourth index is this. The person will really understand, like, this Uche, what is it really for? Is it the name? Is it the address? Then this address is really easier to understand, right? So that wouldn't be a problem. Then we also have this Python. Why do we have the Python there? What characteristics is that? And we also have just a number here. It's difficult for someone to really understand, all right? It will be difficult for you to really understand this after some point. So that brings us to this object, all right? We can create an object, like maybe call that object student or person, and then assign these things that we listed here, like the name, the address, the favorite language, the age, as attributes of this object, so that anyone can create an instance of this object, supply this data that we need, store it somewhere, and access it very easily. So the real advantage here is that using this method of maybe storing and classifying data is more difficult, it's more cumbersome than using things like classes to store this kind of data. And with that part of the way, we are going to look at how to actually define a class, right? I've been talking about classes. How do we actually define this class? And before I get there, I would love to pause for questions. I'd love to pause for questions. Is there any question before we proceed?
For me, no question. I understand everything you said.
Okay. Who else do we have here? Okay, Uche, that was you, right? Mike and Dell,
Yes,
any
sir,
questions?
that was me.
Okay, Mike and Dell, any questions so far? Mike and Dell.
I'm here with you. Sure, sir.
Okay. Any questions?
Not for now, sir.
Okay. Mike, how about you? All right. I'll assume that there is no question. So we are going to look at so far we've looked at how classes are important, right? What classes are, what objects are, what the attributes of a class are. So now we're going to look at how to actually create this class. All right. How do you actually create this class? That's what we are going to look at now. All right. The very first thing you need to know about class is that all class definition starts with the class keyword. What I mean by that is this. What do you see there? That's class. So all class definitions in Python starts with this class keyword. So we can create a class called student. Okay, this is person. Yes. All right, so now we have created a class that is called person. Then this pass here means I'm telling the Python interpreter to ignore everything from there. We'll get to that later. But for now, just ignore everything from there. So this is how you create a class in Python. Right? Then let me show you something. Then one thing you need to take note of before you proceed is that class names are usually capitalized. Right? Writing something like P, though you will not get an error, but it is not, that is not the format that's usually used, right? So class names are usually capitalized. Let's say if you have more than one word in the class name, something like person of something, all right? The next word is also capitalized. So that's that. Then we can actually instantiate this class. Like really, what I mean is we can actually call this class. For example, Uche. Uche is person. Let us go into check and see if there's anything there. All right, so can you see this? We have this main, main.object at blah, 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 blah. This is telling us the specific address in memory that this class we have created is stored. All right, the specific address in memory that this class is stored. This thing you are seeing here is the address, the memory address that we have this class. So we instantiated the first class, which is called Uche. We can also instantiate the second class. Let's call that Bell. Still a person. Then let's print it. Okay. Then another thing I'd love to point out is that two instances of a class are not the same. All right. You know, even when Uche is a person and Del is also a person, they are two different persons. They're not the same. And if you look at what we had here on the terminal, after printing out Uche and Del, you'll see that they are stored at different addresses in memory. The first one is stored as at 0x78 blah blah blah, and the second one is like 0x78 7FD blah blah blah. But if you look at the end of this address, we have 7104 there. and E004 Uche. That goes to tell us that these two instances of person are really not the same. All right, they are really not the same. They're totally different. We can also look at it this way. Uche is equal to the, let us say, if that return true or false. Yes, you can see that we have false, telling us that two instances of a class are basically two different things. So to proceed, we spoke about, I remember I mentioned attributes at the start of this class. For example, we spoke about cars, but I'm going to bring it down into person. All right. Each person has different attributes. For example, Dell's first name is Akintola Matthew, while Uche is Uche and Sandra is Sandra. They have different attributes. All right. Then these are like, should I say, the properties of this person, the attributes of this person, just like in real life. All right. So for you to assign attributes for classes, we make use of the init function. All right. Can you see that? We have def, which is used to define a function in Python. And then we have underscore init, then underscore. Then we have this self. All right, I'll get back to this self later. Then this last thing you see here, the arrow and the none, signifies that this function actually returns nothing. Okay, it returns nothing. When you execute this function, the return value is null. That's what that means. All right, so this self is like a reference to the instance that you are calling. For example, earlier we instantiated this person class and we had something like del is equal to person. All right, this self means an instance of this person, all right, which is del. So we'll make use of it a whole lot again. Right. So the first thing we need to collect, the first attribute we need to collect about the person is the first name. Any person we capture, we want the first name, and we also need the last name. We need the last name, and okay, let me just use name. The name is the name proper. Instead of first name and last name. So we need the name, we need the address. We also need the favorite language. But to save space, let me just call it language. All right, so what this means is, what these things we have here as this argument of this init function, what this means is that whenever you instantiate this class, all right, you need to pass in these values. Okay, so whatever values you pass in will be the properties of this specific instance of the class that you created. Okay, so for now we have here pass. All right, but we need to define, we need to store these values we've gotten here or store them somewhere else. Like we should assign it to the self, this instance of this class, we should attach this value to it. So in that case, self dot, the name of this instance of the class will be equal to this name that we've collected. As such, self.name is equal to name. What that basically means is that if we are making an instance of del, right, and we pass in the name attribute, which is Akintola, all right, that means that this del will have an attribute or a property called name. which is equal to this name that we have entered. Please let me pause here for questions. Any questions?
No, sir, I'm following now.
Okay.
No question from you too.
All right. Uche, any question?
No, sir, I'm following. I understand.
Okay. That's perfect. So when you instantiate the class, all right, whatever values you passed in here, you defined here at the init function, these are the values that you need to pass in here when you are instantiating this class. So for now, we've assigned the value of name. Let's assign the value for address. So the instance of this class will have an address attribute that is equal to the address that we entered. Then the instance of this class will also have a language attribute that will be equal to the language in which we entered. And these values are required whenever you instantiate a class. For example, if we try to instantiate this class without entering those values, right, we are going to get an error. But let's try. Let's check and see if that's true. All right, so as you can see here, we have a type error. We have a type error, person.init. This person refers to our class. Yeah. Person.init, this init refers to our init function. Yeah. So we are told that this person.init missing 3 required positional arguments. The first is the name, address, and language. What this means is that this class that we have instantiated, we have not supplied the name. Okay, this instance of this class, what is the name? All right, we've not supplied it. What is the address? We have not supplied it. And what is the language? We have not supplied it. So the compiler is complaining that he doesn't know this, he needs to do this. So for us to get this to work, we can assign the name as Akintola Matthew, since we are creating an instance of Dell, since we want to define Dell, right? Then the address is 54 Akintola Street. Then the language is Python. So if we compare this, yeah, it should work. Let's see. All right, so we have successfully printed this out, and as you can see, we don't have any errors anymore because we've supplied the data that our init function expects us to have. Okay, so now we've created an instance of Dell. Let us create an instance of Uche. Uche is still a person, so we'll copy that here and then change these variables. We have the first name as Uche, the last name as the address as 54 Uche Street, Lagos, and we have the favorite language as Python. Okay, now let's create an instance of Sandra. Sandra is still a person, so we can copy and paste. All right, so right now we have the instances of all these 3 persons you are working with. All right, so with this, it will be easy for us to it will be easier for us to better understand what each of these data really means. For example, if you are looking for the first name, if you are looking for the name of Dell, all right, we can just print Dell of name, okay, and it should give us the exact name that was passed in for this instance of person. So if we print that missing one required positional argument language, okay, there's an error here. Let's look. Let's hunt it down. Okay, the problem is with Sandra. All right, the problem is with Sandra. We've seen here that the init argument, the init function takes name, address, and language. But when we instantiated Sandra with person, we only passed in the name and the address. We did not pass in the language. So that's why we are having this error. Type error, person.init missing one required positional argument language. And if you read a little bit up of the traceback, you can find that our error is at line 14. And at line 14, we have this instantiation of Sandra. And that's how I knew that the issue is Sandra. So let's add a language for Sandra. Let us say that Sandra's favorite language is C++. So if we print this out, we should know how that error is. So as you can see here, when we printed out an instance of Dell, all right, and called and access the name attribute of that particular instance, we saw that the name is Akintola Matthew and not Jude, not also Sandra. So that goes on to tell us that each of these instances are like they are different objects completely. All right. So let's also print the name of Uche. Uche and Sandra. Uche and Sandra. So as you can see, this instance of the object that is Uche return the name Uche. And this instance of the object that is Sandra returned the name Sandra. So I would love to pause there for questions. Like you've seen how a class is defined so far. We've looked at how to instantiate a class, all right, taking the attributes of this class, okay, and assess these attributes of this class. So please, is there any question on that, or is there anything you would love me to explain more? Okay, let's start with Uche.
Okay, for me, I understand everything you have said. I understand. Actually, I actually have knowledge of this before now, so I understood everything you have said. Where you define self.language, the language there, the second language, that is self.language equal to, you didn't spell it well there. So just to spell that second language well, so that if you are calling the method, it will not give an error.
Oh, you're right. You're right.
Yes, sir.
You're right. There's a spelling error here, and Uche, thank you for pointing that out. So
right,
language is language. All right, Mike. Any questions so far? Dell and Ihema. Yes, Mike.
I don't have a question.
Okay. It's okay. That's good to know. That's good to know. So if you have any question, you can drop it on the chat, and I will go through that. Let me check if there are questions. Chat. Okay, that's perfect. That's perfect. All right, let's continue. Okay, so far we've looked at instance attributes. All right. When I say instance attributes, we are referring to the attributes of the particular instance of this class. All right. Let's say the name you pass into the first instance of this class is different from the name you pass into the second instance of this class. It's different from the name that was passed into the third instance of this class, all right? So as a result, these are called instance attributes. They are attributes that relate to the instance of this class that you are calling. Then we have another type of attributes that is called class attribute. And class attributes are the same irrespective of the instance of the class. Let's say I define that normally a person breathes. Okay, a person breathes. So this is a characteristic that is general, like I breathe, Dale breathes, Uche breathes, Sandra breathes. And that falls under class attributes. Don't forget we are working with class. We are working with a person that is a class, right? So we can define an attribute for a class. To do that, you don't put that attribute inside this init function, all right? You define that attribute outside the init function. So in that case, we can call this breathe is true, right? Breathe is true. So this breathe that we defined here is a class attribute. It relates to this class. Every single instance of person definitely breathes, right? So it is not related to a specific instance. It is related to every single instance of this. So what this means is that since this attribute is related to all the instances of person, every single instance of person can access this attribute. For example, we can call del.breathe. We can call Uche. We can also call Sandra.breathe. If we print that, we should have true, because that was a class attribute. All right, it is an attribute that is general for every single instance of this class. Any question on that?
I understand.
Okay, so I believe with that now, you should be able to differentiate between instance attributes of a class and also the class attributes of each class. Any question on that? Who? Mike? Okay, Dale, any question? Ihame, any question?
No question, sir.
Okay. All right. So at the start of this class, I explained that each object, like a person, has both attributes and properties, right? So we gave an example of a car, and a car has an attribute like the color is an attribute, right? Then it also has something like, what word did I use there? Was it property?
No, I think it's attribute.
Yes, I said attributes. Then I also said something else. Yes,
Okay.
I think I used behavior. Right, I used
Yes,
behavior. Yes, what it does. All right, it's different from what it is. Take for example, a person. You have an attribute like your name, but what you do is different. All right. So these behaviors in object-oriented programming are what we call methods. They are called methods. Let me write that down. Methods. More specifically, instance methods. Okay. So to define a method for a class, you you define that method after this init function. Let's do that practically. So as you can see, let's define a method called speak. And just like the init function, every single method takes the first argument, and the first argument has to be self. Right? Like here we have self. Oh, sorry, I muted you. So like here we have self. So we can define this method because normally everyone speaks, right? Every person speaks, though not all, but most persons speaks. So we can maybe define what this particular function does. We can return something like self.name. We are accessing the name of this particular instance. Speaks. Self.language. So self.name speaks, self.language. So when we instantiate this particular class, we can then access that behavior. We can then access that method and get it to do whatever we want it to do. And in this case, we want it to return a string that the name of this instance speaks the language of this instance. So let's write that down. If we call an instance girl is equal to person, and we pass in the properties of the with this we just as we are able to print out the name of the address of and the language of we should be able to call this behavior there, which is to speak. All right, so let's try that out. Print the speak. Type error. Nice. Person init takes 4 positional arguments, but 5 were given. All right. So, you know, debugging is a natural part of programming. So the problem is that line 16, if you look at the trace back, we have at line 16, we are told that del is equal to this. And we are given a type error. Person init takes 4 positional arguments, but 5 will given, right? So these are the arguments you are supposed to receive: name, address, and the language. But we are giving address to resolve that. Yes, to resolve that, we simply need to take off that and call this function. All right. So we can see now that Akintolama speaks Python. All right. So to recap, the method, okay, each person has attributes and behaviors. Okay. So we can model these attributes as just attributes in a class, but we model these behaviors as methods. That's the name, and their functions. All right. The first behavior we are looking at is speak, because every person speaks, and we want this to like speak literally. All right. So when someone calls this speak method, we want it to return that this person self.name speaks self.language. As such, when we instantiated Akintola as Dell, the name is Akintola Matthew, and the language is Python. So that's how we got Akintola Matthew speaks Python. So let's try that with someone else. Let's do that with Uche. Uche. And let's also do that with Sandra. Right. Good. So we have an error in this code. Who can spot the error?
I believe it's from, okay, the Uche variable, there are two Uche classes, Uche objects. We didn't change the third.
Okay, yes.
Then another thing,
apart from that, there is another error.
The 23 there is an object. I believe maybe Python is seeing it as an integer instead of a string.
No,
23
I think
there.
the problem is the person is taking 4 arguments. So there's no age. He's passing the age. Am I right?
Perfect. Perfect.
Okay, no. Sorry.
You're right.
It's an integer. It should be a string first, and it's also taking an age.
Yes, I feel that 23 is an integer, and it may not. I don't know, but I think that's the issue is with that 23.
Yeah, 23. Yeah, because it's still 4 arguments. It's still 4 arguments, irrespective. I think if you change it to a string, I think that should be the problem.
No. We actually had an
Really
error
run the
before.
code. Let's see.
Yes, we actually had an error before concerning this. All right. The thing is, okay, let's run this code. It will fail for sure. What?
Yes, I didn't expect it to fail because
okay. It's
true. The same argument, yes.
It's true. That's not what I wanted to model.
It should fail now.
Yes, it should fail now. All right. So why would it fail? What would make it fail?
It is 4 arguments. It is passing in a 5 argument instead of 4.
Yes. That's perfect. The init function expects 3 arguments. It expects 3 attributes instead of 4. So if we run this, we'll get a type error. So I'm actually showing this error so that, because like programming is all about like software development, and it's all about spotting errors, it's all about debugging. So as you are learning, it's always good to make these mistakes and learn to read error logs, like go to the error log and look for where the issue is. So if you look at it, we have traceback, most recent call, last at file. This is my directory, home 18 desktop, KodeCamp, Python, intermediate, then OOP. That is my directory to this specific file. And now that we are in this file, like where exactly is the error? The compiler has been kind enough to tell us that it is at line 18. And it has printed what we have there at line 18 and has showed us the error that we have. And it is a type error. Who is that? Please, can you mute yourself? Intro. Okay. So the interpreter has been kind enough to tell us where our error is, where our issue is, that this person.init function take 4 positional arguments, but we have given 5. All right, but we have given 5. But have we given 5?
No, actually.
That's an important question.
No.
Counting the self.
No.
Yes, we have not given 5, but why is the compiler or why is the interpreter telling us that we have given 5?
I guess it's counting the self.
Yes, perfect. Perfect. You know, I mentioned at the start of the class that whenever you instantiate a class, or you are calling an object of the class, all right, the interpreter automatically assigns itself, which is like saying me, like it assigns that self automatically. You don't have to do that. So in that case, there's no need for us to maybe include something like self here, all right? It's wrong, it's unnecessary. So the interpreter automatically assigns that. So it has assigned that, and then we assigned 4 more, giving us 5, which is wrong. The init expects 4. So we just need to remove this and we'll be fine. All right, Sandra speaks 23. We've gone a long way. So any questions so far? Any questions?
Yes, I'm yet to understand the place of self. That self.
You said what?
The place of that self. You said you passed in a self before, and I don't know what you removed that solved the error. So,
okay, that's
you get my question.
Error.
Yeah,
no,
I think
no, I
we're having issue with self. We're having issue with self before. Do you get
yes,
now? You said the 4 arguments, which was 5 based on the fact that there was self.
Yes.
So, but I don't know what was done that solved the error.
Okay. Let me go through it again. Right. So I explained initially that whenever you call this init, define this init method or any other method in a class, the first argument you need to pass is self. Right. When you define like init, the first thing we passed was self before we pass name, address, and language. Then we did the same thing with speed. All right. Then the thing is, this self is like it's giving it should I say a link to itself, just like self. It's something like myself. All right. So with this, we define that self.name is equal to name, meaning my name is equal to this name that you've given to me. For example, if I renamed this to full name to make it much clearer, full address and full language. Yes. So we can then rename this to full name. What this basically means is that you are defining that my name is equal to, sorry, this should be full name. Not this. What we are basically saying here is that my name should be equal to full name. Then my address should be equal to full address, and my language should be equal to full language. So this self, it gives it a link to itself. It's like saying me, man. All right. Now, when you instantiate a class, that's self is passed in automatically for you by the interpreter. You don't need to pass it again. Okay?
Okay.
Now, the problem we had here at line 18 was that we defined something else. Test, for example. So when we try to run this function, it will fail. Why is it failing? Because we're supposed to pass in 4 positional arguments, but 5 were given. We gave Sandra 54 Sandra Street, that's number 2. Test number 3, 23, number 4. But why is the interpreter telling us that 5 were given when we only entered 4? That's where that self comes in. Don't forget that I told you that when you are instantiating a class, that your compiler has this, the interpreter has this self for you automatically. They don't need to add it, all right? So it is counting that as well. 1, 2, 3, 4, 5, all right?
Okay.
We've passed in 5, but our init function was expecting 4, hence the error. Okay. So the thing is, there's no need for this self, all right? There's no need for this test. There's no need for this test. So now, since the interpreter has passed self in for us already. We only need to pass in full name, address, and full language, which is only 3. So now we have 1, we have 2, we have 3. With that, a program runs. Please, do you understand? Well, any other question?
Yes, I do. Yes, I do. Understand perfectly.
Okay. All right. Now let's go into something else. Let us go into something else. All right. So instead of printing this, let us print. Okay, like what exactly does the print statement do? That's the first thing we need to understand. Let's say if we have a list, my list, which is equal to 1, 2, 3, 4, and then print my list. What we have, let's see that. We have this displayed on the screen, the contents of that list. It converts it to a string and displays it on the screen. So what happens if we print this there on it? What we see? Let's check. All right, we can see that it is a person object at blah 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 address in memory. Like, why hasn't it maybe printed something like this for us? The properties of this thing that we passed in, the properties of this person that we passed in here. Why hasn't it printed that for us? It is entirely possible for you to get this data out. All right, it is totally possible for you to get this data out. It's just that we need to do it differently. Let me pose for questions. Any questions on that?
Okay, no question from my end. No question.
Okay. Okay. So there's a way we can get the exact details of this instance of the class to be displayed for us when we call it. Right. So let me use the unofficial method first. Let's just call this description. Let's call this description. And we want to define a method that will maybe summarize all this data that we have here for us. All right. So we want to return string interpolation of name, self. We also want to return the address of this is slight error. I'll resolve that later. So the address. Then we also need the language, which is language. So hopefully this this method should return this, but there's a problem. Who can spot the problem for us?
You didn't put self after description in the parentheses after description.
Yes, definitely. We did not put self. All right, there's no self there. With this one, I don't know. Let's check. Description. Let us see. Will it run? What do you think?
No. It's only trying error, I guess.
Okay. Let us check. To be sure, let us check. If it's wrong. Can you see that? We have this traceback. As usual, the interpreter has been kind enough to give us where our error is, all right? And we have a type error. Person.description takes 0 positional argument, but 1 was given. How? Did we give anyone?
The self was passed automatically.
Yes,
Yeah,
the
the
self
self
was
was
added automatically,
automatically.
but we did not configure this method to receive self. So that is why we have that particular error. So to resolve that, we just need to pass in that self argument, right? Pass in the self and run it again. So the second run succeeds because we've passed in the self. As a result, the method is able to access its name, it's able to access its address, and it is also able to access its language. So I told you that there's a more cleaner method of getting the description of an instance of a class. All right, instead of defining a description method and then calling that description method when you need the description of the class, there's what we call the underscore str underscore. Can you see that? It's very similar to init. All right, you use init to get the properties, the not properties, the attributes of the particular instance you want to create. All right, then we use this string underscore str underscore to display whatever you want to display. All right, when this class is printed on the terminal, what do you want to display? So you put it over there. So let's try that out. Hopefully, what we got when we printed del.description, we should get the same thing by printing just del. Good. So let us print del. All right. So you can see we have the exact same thing. Please, do you have any question concerning that? If we commented this del out, okay, if we commented this string method out and try to print this class, you can see what we have here. We have a person object, blah, 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 blah. It's only giving us the memory address of this particular instance of person. But including this string method return something for us. All right. Whenever we print that class, it returns something. It doesn't have to be what we've returned. It can be anything. You can just print hello or just anything whenever you're printing this class. So with that, instead of having main.person object blah, 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 we have the name of this instance, the address of this instance, and the language of this particular instance. So this init and string are called Dunda methods. Let me type it for you. Let's see, thanks. Dunda methods. They are called Dunda methods. And why they are called Dunda methods is because we are beginning the name with underscores. Just like in it, we have 2 underscores at the beginning and we have 2 underscores at the end. Then we are also having the same thing for string. That is why it is called Dunda methods. Okay, let me pause there for questions. Uche, any questions so far?
No, sir, I understand everything.
Okay, Dale, how about you? Any issue?
No question for now, not at all.
All right. Henshaw, any question?
No questions. No
Okay.
questions.
Ihema or Ihamen, Gilbert, I believe no question. Mike, no question, I believe too.
We asked a question previously, Shabo. I think we answered him in the chat section.
Okay. He asked a question in the chat. I didn't see that. Let me check. Sorry about that. Sorry about that. Charts. Okay. What is the meaning of breadth? Breadth is equal to true. Okay. So we spoke about instance attributes and class attributes, and we said that for an object like a person, right? For an object like a person, they are instance attributes. This instance attribute means each person has its own attribute. For example, me, my name is Yatim, all right? We have Del, and the name is Akintola. We have Uche, the name is Uche, all right? These are attributes that are peculiar to each instance. Then there are other attributes that are not shared, like the behavior. The way I behave is completely different from the way Del and Uche behaves, right? Then we also have other attributes like the donation, the way we speak, and all of that. So these characteristics, right? These characteristics are characteristics that are unique to each person. So that is why we call this instance attributes. Each instance of a person, I am an instance of a person. These are my attributes. They are unique to me. Dale is an instance of a person. His attributes are unique to him. And Uche, Sandra, everyone, we are all instances of persons. All right. Then there are some attributes that are universal. Like every single person has this attribute. Every single person has this characteristic. And one of it is breath. All right. I can breathe. Like now I'm breathing. You can breathe. Everyone can breathe. All right. Then we have there are other characteristics. There are other features and attributes that are shared across persons. Things like to breathe. Then things like maybe to eat, maybe to speak, etc., etc. These are characteristics that are shared across. Right? They are shared across. That is why they are called class attributes. That's why they are called class attribute. Every single member of that class, every single instance of that class inherits that attribute. You don't need to assign it manually. They inherit it automatically.
Okay.
All right. Okay, so Ihema, do you understand that?
So there's a class, Zoom class I'm following, the programming class.
Okay, please, can you mute yourself? Who is that? Which I believe? That's good.
Yes, I've done that.
Okay, so we are going to proceed from that. Okay, before we do that, like, do you all really understand what we're talking about here? I believe there's no question so far. So to make this more to make it easier for everyone to understand, I will give more examples. I'll give an example. In this example, we are using person, right? In the next example, I'll work with cars, right? I'll work with cars so that you get the chance to maybe understand it better. Right? So I'll create a new Python file, touch OOP2, OOP2.py. So we'll go there and work over there. So we are going to create a class that's called car. All right. Then we are going to define the init method that will take in the attributes of this car, of each car that we want to create. And as usual, each init takes itself and some attributes. All right. So what attributes of cars do you know? You can drop in the chat. What attributes of car? Yes, colors. That is from Henshaw. We have color. Who else?
Let's say the
Model.
engine type,
Good. Engine type.
like V8, V2. Okay, let's say I don't know the number of tires. Maybe some vehicles, some like bigger vehicles have, 18 tires, or maybe 22 tires.
Yes. That's perfect. Let's say number of tires.
Passenger seats.
Okay. Perfect.
Passenger seats.
All right. Seats. And I think let's say year of manufacture. Yeah. Let's talk about that. So now we've created this car and we want to initialize it with its properties. All right. So as usual, we have self.color, meaning my color is what? Let it be the color that we get from its initialization. Then my model, what is my model? That's what that self basically means. My model is equal to model. Then my engine type. Is equal to engine type. Then we are going to do the same thing for the remaining three. First tires and seats and gear. Tires is equal to tires. Then we have seats. Is equal to seats. And then we have year is equal to year. So after the init, we can optionally define a string method, which will just return these basic details or whatever we want to see when this class is printed. So let us define a string which returns a string. This one returns none. Let's define the return type. So with this string, I would not be able to type in all of these. So let me just type self.model. Okay, so I'm returning that my model is a nice car. In addition to that, let us create one more method which will return the year, maybe year plus 5, right? Let's def return, okay, def year plus 5. And as usual, it gets self. Okay. Maybe instead of adding 5 to the year, all right, let me show you something new. All right. Instead of adding 5 to the year, we will make this method take an argument. And we'll call that argument number, and it will be an int. So this should return a string. This particular method should return a string. So what will happen here is that this method will return the year of this particular model of car. So we call that self.year. And then add 5 to it. Just, okay, not add 5 to it, add whichever number that we have provided to the function to it. Good, so with this we are done. We can then instantiate this class. Let's say Honda. Honda is an instance of class. And for the first color, let's use red. Then for model, of course, it's Honda. Then we have engine type. I don't really know what engine types are. Let me type any string there. Then tires, it should take 4 tires. Then seats, 4 seats, and year 2019. I believe we have the right number of arguments. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, that's correct. So let's instantiate another class, and let me call this messages or Volvo. Our Volvo should be clapped. Volvo. Then as for the engine type, let me say 45RE. It has 4 tires, it has 4 seats, and it was manufactured in the year 2017. So I can choose to print this Honda, and I can also choose to print. Let me print Honda and Volvo. Then I can also choose to call this method year plus. All right, year plus takes self, and don't forget that this self is entered automatically. So it takes that self and then takes an optional number. Okay, not optional, a compulsory number. This number has been passed in. All right. Before I get to that, let us print the base. Let us print the base instant first. Nothing. What? String return this. Oh, sorry.
You use touch.
Yes. Sorry, it's a mistake. Python 3. Very good. So we have that Honda is a nice car. That's for Honda. Don't forget we return self.model, and our model in this case is Honda, and it's a nice car. Then we also have Volvo is a nice car. Now let us print the year plus. Let's execute the year plus. Year plus. And year plus. Do this one. This one or who can tell me why?
No.
Why won't it run?
Set argument number.
No argument.
Yes.
No number argument.
Good. So year plus should take a number argument, and in this case we have not entered that number argument. Let us check. All right. As you can see, the trace bar at line 19, we printed Honda.year plus, then Volvo.year plus. Then we have a type error, car.year plus, missing one required positional argument number. So that's how you debug your code. All right. The interpreter will help you do that. In this case, we have missed the required positional argument, which is number. So we need to input that. 5. Now we want to add 5 to the Honda year, and I want to add 9 to the Volvo year. So let's execute this again. So as you can see, we now have the correct value we expected. Honda year is 2019. So if you add 5 to it, you have 2024. Then the Volvo year is 2017, and if you add 5 to it, we have, okay, if you add 9 to it, we have 2026. Okay, so any question on that?
Yes, I understand.
Any? Okay. Who else? Do you have any question? Okay, that's perfect. So this class will end here for today, and in the next class, we are going to look at inheritance. That's class inheritance, right? In Python, it is possible for a class to inherit the properties of another class. Just like me, I'm inheriting from my dad, my mom, and the rest of that. So it is possible for a class to have a parent class and a child class. So that's what we are going to look at in the next class. So for now, we are going to stop here. So I gave an assignment. I posted it on the Slack channel. So please do well to do that and send that to me ideally this evening. Send it to me as a PM on Slack, ideally this evening. Then as for this code, I'm going to create a repository on GitHub, and I will push this code to that repository. When I'm done, I'll drop the link to you on Slack so that you can clone from it and go through the code yourself. I think with this, we come to the end of the class. Thanks for attending. Bye.
All right, sir. Thank you very much, sir.
It's okay. Thank you.
Exactly.